Assalamualaikum. For our presentation, we will present and explain about our project, which is a smart building with an automatic door and fire alarm system. But first of all, I'm going to introduce myself and my team members. So my name is NORRAPIDAH binti Muhammad SHARPI, and the other two members are either SYAFIQAH binti SUDIN and Farzana Fatin binti AHMAD JAMALI. For our job description, we divide the works equally as shown in the slide. For the introduction, we developed smart building automatic door system and fire alarm using servo and gas sensor respectively. To fulfill this project, it was conducted by using Tinkercad software that is available on web browser. The automatic door industry is expanding and getting more specialized. Many commercial buildings and infrastructures, such as shopping malls and airports, as well as industrial settings, have automatic doors. They come in several styles, such as sliding, swinging, folding, and so on. For fire alarm system, it is designed to alert us to an emergency so that we can take action to protect ourselves. Fire alarms are found in offices, factories, and public buildings. Whatever the method of detection is, if the alarm is triggered, sounders will operate to warn people in the building that there may be a fire and to evacuate. So for the problem statement of this project, as we know, manual door or non-automatic door in the building, such as pressing on door handles, pulling or pushing doors, and closing doors again after passing through, it can all be annoying at times. People also often forget to close doors after themselves in particular. And for some people, such as wheelchair users, children, older people, or the disabled, opening a door and then closing again is impossible. Following that, manual door did not promote better hygiene standard because individuals must touch the door to open and close it. This will spread disease among individuals who utilize the building daily. In certain situations, problem of the non-automatic door is a failure to reduce body-wide energy use. These non-automatic doors are prone to being open and remaining open, particularly in hot weather. Meanwhile, for a building that didn't provide a fire alarm, this will not provide proper level of protection and give the danger to the user or the people in the building. This is due to the fire station got delayed information about the fire that occurred. Also from people on the building inability to get warning and to know there is a fire. And as a fire has been causing great damage to life and property many times in our country, we developed the idea of creating this project. It will be of great use in each and every household as well as industries and factories. For our objective of this project for automatic door system, we want to develop an automatic door system to apply it in real life that can discover by using Arduino Uno, ultrasonic distance sensor, and servo with the latest technology by using the Arduino Tinkercad program. We also want to design a system that can detect the presence of object or human. And we also want to create a hands-free operation for automatic doors, offer an optimal solution such as reduced time, energy saving, reduced cost, and hygiene control. So for a fire alarm system, we designed a fire alarm system to apply in real life that can discover fires early by using Arduino Uno, gas sensor, piezo with the latest technology by using the Arduino Tinkercad program. We also want to design a system that can detect the presence of gas or smoke and want to increase the speed of rescue operation and restricting the spread of fire and structural damage and valuable assets. And also to provide early warning and ability to the people in the building to know there is a fire to prevent smoke inhalation, ultimately resulting in deaths.
Assalamualaikum and hi. Now we'll proceed to product description and details. Firstly is ultrasonic distance sensor. It measures the distance of a target object by emitting ultrasonic sound waves and converts the reflected sound into an electrical signal. Next is microservo. It has an output shaft that can be positioned to specific angular positions. Next is Arduino Uno R3. The Arduino Uno R3 is a microcontroller board based on a removable dual inline package, which is DIP AT-MEGA328 AVR microcontroller. Next is resistor. It is a small semiconductor which resists the flow of electrical current. The current is permitted to flow but is reduced by the value of resistor. Next is wire. It is used to bear mechanical loads and to carry electricity and telecommunications signals, and also allow electricity to flow from one device to another. Next is breadboard small. It is a rectangular plastic board with a bunch of tiny holes in it. Next is LED, which is called light emitting diode. It is a semiconductor device that emits incoherent narrow spectrum light when it is electrically biased in the forward direction. Next is gas sensor. It detects the presence or concentration of gases in the atmosphere. And lastly is piezo. It generates a voltage when it's physically deformed by a vibration, sound wave, or mechanical strain. Next, I will show you the circuit diagram. This is the circuit diagram that we create for this mini project. The components used are the one that I mentioned just now. This circuit shows the current from the Arduino Uno R3 will transfer through the wires for the component to operate. The micro servo, which acts as a door, and the piezo will automatically operates when the object and gas is sensed by the ultrasonic distance sensor and gas sensor at a fixed amount of distance. Those components will also operate at a fixed amount of time. Okay, now I will show you the flowchart for our project. Firstly, from fire alarm system, we can see that the input is gas sensor. If the gas sensor is more than 150, the piezo will produce sound. Meanwhile, the red LED will light up and the green LED will turn off. If it is the opposite, the piezo will not produce sound. Meanwhile, the red LED will turn off and the green LED will light up. Next is the automatic door system. The input here is the V distance, which is the ultrasonic distance sensor. If the object is less than or equal to 100 cm from the door, the micro servo will rotate 90 degrees. When it is the opposite, the micro servo will rotate 0 degree. And lastly from me, this is the coding for our project. Now, we will go through the coding of the law system. The variables here is gas sensor and V distance. From the coding, we can see that if the V distance is less than or equals to 100, the servo will rotate 90 degrees and it will operate after delaying for 2 seconds. Or else, the servo will rotate at 0 degree. Then, if the gas sensor is more than 150, the pin number 4 and 2, which is piezo and red LED, will operate after delaying for 2 seconds, while pin number 3, which is green LED, will turn off. Or else, the green LED will light up while the other two components will not be operate.
Assalamualaikum warahmatullahi wabarakatuh and hi. Now I will proceed the presentation, which is the result for our project. As per explained before, for our door system, we observed that when the distant object is more than 100 cm from the ultrasonic distance sensor, the servo will not rotate. Otherwise, when the distant object is less than or equal to 100 cm, the ultrasonic distance sensor will rotate to 90 degrees, and each rotation that servo make will take 2 seconds. And for fire alarm, if the gas sensor detect less than 150, the piezo will silent and the green LED will light up. Otherwise, if the gas sensor detect movement of more than 150, the piezo will buzz up and red LED will light up. Next, for our discussion, variable V distance was set to read input distance sensor and was set to detect value less than or equal to 100 cm to micro servo rotate for 90 degree. Or else, if the distance is not as declared, the servo will not rotate or turn back to original position. Plus, in coding, we declare for each rotation servo made will delay for 2 seconds due to avoid any accident occur before closing and opening. For the fire alarm, when there is appearance of smoke is more than 150, red LED will light up and piezo will produce sound to alert the surrounding. But if the smoke is less than 150, the piezo will silent and green LED will light up to notice for the safety situation. However, some recommendations should be considered for better future studies. First of all, include a remote component to control the movement of the servo, and second, addition of automatic water sprinkler system to reach automatically in the event of fire and for safety concern. And last but not least, addition of reset button for fire alarm. In case it is a false alarm, then we can reset the system and return to regular operation. Finally, for our conclusion, our project was done successfully by using Tinkercad, and it's helped our project becomes easier because it is low production cost and user-friendly. We can say that our alarm triggered when there is appearance of smoke and we managed to achieve the objective of this study. Moreover, fire alarm is important to us because when the fire happens, smoke tend to spread farther and faster than heat. That is why mostly victims die from inhalation of smoke rather than burn. If fire alarm being installed, it will stand guard around the clock and providing the early warning of a potentially deadly fire. And finally, for our automatic door system, which is the servo rotate as per our demand, and servo on one of the vital device that been used till today. Many company continue rely on servo because of their reliability, their precision and efficiency. And that's all from us. Thank you.